I'm here today to talk to you about what I consider as reasonable software, rather than trying to fit it into any kind of current paradigm or anything like that. I want to just talk about what it's like to be a reasonable software developer, what it means to be a reasonable software developer in your teams, and what it means to have reasonable code. So a bit about me. My pronouns are he, him, his. I've been a software developer for 18 years. I'm currently at Redgate, as you've heard. I'm quite passionate about maintainable code. I want to be able to look at a code base and think, yeah, I know how to work with this thing, rather than getting confused and spending hours stuck in the mud, which is where this talk comes from. And with the little character that's at the top there, I do a little bit of doodling and sketching and sketchnoting at various conferences. So what I'm going to talk a little bit about today is what I consider reasonable, how to be a reasonable human, thinking about some reasonable user interactions, how we can talk about the qualities of our code base that make things less reasonable, and what tools we could apply to maybe fix that. And I'll take a look at some code that I think is less than reasonable. So what I mean by reasonable about any process is that you shouldn't have to look outside of your current level of abstraction to understand what you need to do. So if you're looking at a piece of code, I should be able to look at the high-level architecture without having to understand the details of what's needed to be done, or I should be able to look at the details and be able to infer what the parts of the system are interacting with me do or need. But almost anything in the world can be reasoned about if you put enough time, money, effort into it. But we tend to conflate the idea of things that are complex with the stuff that we do to make things more complicated. So I call that accidental complexity that we put into our systems. So the domains that we work in can be justifiably complex, and they will need complex solutions. But we should add no accidental complexity into that solution. We should try and make it so that the only thing that we're having to think about is the domain that we're working in. So I want something to be reasonable with the least amount of effort. And what do I think of as reasonable? Well, I want something to be cleaner. I want smaller components that I can understand without having to understand the entire code base. I want things to be loosely coupled so that I can change the behavior by just injecting something different, by writing new code rather than modifying the old code. I want things to be predictable. What I don't want to see is massively different coding styles, massively different ways of writing code in the different parts of my system. I don't want to open one file and find something looking one way, and then go to another file and go, oh my God, what is happening here? And I think I also want clear responsibilities, so that I understand what the job of the thing that I'm doing is. And most importantly, does it fit in my head? Can I hold the task that I'm trying to do and the code or process that I'm trying to work with in my head at this time? Because if I can't, then I'm going to spend too much time on it, too much time understanding it. I'm going to get stressed. And these apply to organizational principles within your companies. If you've got a process that needs 5 directors' approval, and you've got to try and find out who those directors are, what they're doing, they're going to be on holiday different times, things are going to be more complicated for you to get something done. So we can apply a lot of these principles back to every part of our life if we just take the time to understand what we're trying to do. So being reasonably human, it's the best term I could come up with. I want to be a reasonable human. But we can break it down into what does it mean to be a reasonable company? Because companies are made up of humans. We tend to forget that. We tend to see them as these entities in themselves, but companies are all humans from the top all the way down to the bottom. What does it mean to be reasonable in the team, with your code base, and with the users? So companies should have really clear values. There's a classic one that we had from Jeff Bezos, which I think he was a bit of a dick about it, but everything is going to be an API. That's a really clear value. And if you write that API, it's got to be written as if somebody else from outside the company could use it. That's a very clear value that everybody had to learn to appreciate. But I think that Bezos went down the stick route, or you'll get fired. I think that actually you can do a lot by rewarding those values, by really praising the people who actually do what you've asked them to do, rather than just going, rather than the more draconian approach of killing people, like saying, right, that's it, you're gone if you don't do this. We need well-defined policies so that I need to be able to make a decision at the right level for me. Sometimes decisions go beyond me. I'm a developer. I can deal with architectural decisions in the product. I can deal with some of the product direction. But there are times when the board decide this is not a direction we want to move in. And they should be making that decision. And I should be making I should be autonomous within the boundaries that they're trying to give. But those clear boundaries do give us autonomy to do what we want. But at the same time, no boundaries makes people afraid. I've had it in companies where people have said, you are completely autonomous, do whatever you want. We design what we say, this is what we're going to do. They go, no, try again. And you go, what do you mean, try again? You go, well, autonomously come up with a different decision. And there's something in their head that they're not telling us. There's some information that we're missing, but the boundaries have not been set for our team. We just have to keep going back until they tell us, until we get the right answer. So the final thing that I think we should possibly, that I think I need as a developer, is a vision of where we're going. And some people will argue, well, you're agile, you have to adapt, but I see it more as, we're going over there. We start doing small pieces of work to validate what we're doing, to get there. That can feed back to me, and that vision can change. I don't mind if we're going from there to over there, but if you have no vision, and you're constantly doing small pieces of work, it becomes a bit aimless. People can't actually say, is this working towards the greater vision of what we're doing? And within our team. Again, each team within an organization is going to have some values, and those values are not going to necessarily reflect or be identical to the same values of the company. We're working on different products, we're working in different ways of, in sometimes legacy, sometimes we're working on greenfield projects. Sometimes we're working on something so experimental we don't even know if it's going to be a code base in 3 or 4 months' time. All of those have different values that we want to, like the ways that we approach software will be different. So be clear in your team how you're going to work. There's no point if you think this is literally a prototype that we're going to throw away, spending half your time writing tests. Though the caveat of that is, we are going to throw it away, which doesn't always happen. So get your team to state the clear values and to hold each other accountable to those values. But then part of that holding each other accountable is understanding your colleagues. What do they like doing? What do they not like doing? What are their strengths? What are their weaknesses? Even getting down to how they're feeling. You know, if you, I know recently a colleague lost his father. He's not thinking about software in the same way while he's trying to deal with the grief of dealing with his father. So you change how you behave based on how your team are feeling. And one thing that we're looking at doing at work at the moment is having a kind of a emotion slider. where you can put where you are on the emotional scale. And for me as well, I become more aware of my own emotional state. So I've stopped meetings before because I've been defensive. There's no way that I am going to be constructive if my brain is completely in defensive mode. I'm not taking in anything that people are saying, so I just go, I'm not in the space right now, give me half an hour to calm down and we can carry on. But that's about me being then a responsible and reasonable team member. People can't predict my actions if I'm defensive, but they can probably predict me better if I've taken that time to calm down and to, or even just to let them know that I'm defensive. They can predict my actions. If you're not clear about how you're feeling with your team, then they can't predict you. They can't understand where you are. They can't take into account what you're feeling. And I think then we can get to the point where we can discuss things clearly and we can get clear tasks of what we're trying to do. I found over many teams that a 3-word note on a Kanban board doesn't tell people what to do. It really doesn't, because people don't always think the same way. And we've had wildly different approaches to how we'd approach the same problem. So why don't we actually put a definition at least down on that card so that we can more objectively state what we're trying to achieve? Sometimes that can be just getting 1 or 2 other people together, talking about the problem and agreeing that that's what's going to be done. But if you're doing it by yourself, sometimes things are going to take time or effort, or you're going to do things that other members of your team thought, why the hell are they doing that? And that's all down to how you are interacting as a team. So as part of that, everybody needs a voice. Everybody in your team should feel like they can raise an issue. As a senior developer, I should be held accountable by the junior developer if we're not holding ourselves to the values. They should be able to say, why aren't you doing this? But that means that they have to feel safe. I can't jump down their throat. I can't just go, oh, sod off, get lost, you're only junior. I'm the senior person here. I'm doing what I want. So therefore, make sure that people actually feel safe in the team. And one way of doing this is probably, if you do retrospectives, to get an anonymous sort of tick box of how safe people feel. Just make sure that people try and tell you whether they feel they can speak up, or even sometimes get the junior people to speak up first, because then they're not contradicting the more senior people in the team, and they can more openly express their opinions on what's gone wrong or what's happened. But automate what the hell you can, because that way, if you've automated your coding, like guidelines in terms of whether you use tabs or spaces, whether you use carriage return line feeds instead of line feeds, whatever you're doing, automate it if you can, because then you have an objective way to make sure that your team is agreed on what they're doing, rather than different pull requests, people pulling things in different directions. Be reasonable in the code. So if I often work on things within Redgate that are internal libraries that people use. What should be the first thing that people see in that library? Should it be how to use it? Probably, because most people are looking not for how to change that code. They're probably looking for how to use it. But in my main code, in the apps that I'm working on, it's probably the people coming here to write the code. They might be new to the team. So the getting started guide on how to get the environment up and running, how to get things working, what license keys you need, where to get them, how to get things on your machine, how to set up your dev environment, all of those things become more important. But think about the context of your consumer. Think about who is trying to use it, for what reason, and make sure that you've put the most common thing first so that people can actually use it efficiently. But then always have contribution guidelines. Every one of the repos that I work on has contribution guidelines. And then we have to hold ourselves accountable. If another team comes in and does some work on our project, they should be held accountable to the same standards that we hold ourselves. And if we're not, then we're not reasonable. They can't reason about our code. They can't reason about our processes. And try and aim, where we can, for clear and consistent APIs. If the company has a style of how to write an API, you shouldn't be really going against that unless you've got a really good reason. Unless you can prove to maybe a higher authority or to a group of your peers from other teams that you definitely need something different. And like on the more human aspect of things, be reasonable with your users when you're designing UIs, when you're working with the user interface or even your APIs. Think about what your user's going to do. Put yourself in their shoes, but realize that you are not the typical user. You are too close to your product. You've spent too long thinking about this problem, designing the problem, working on the solution, that I know on all the stuff that I work on, I can get within seconds going through the UI flow to set something up. But that's because I'm setting up a really simple case. I'm setting up something, like I work on data masking solutions, so I already have a database there. I already know where it is. I follow the same procedures. I got the keystrokes down to the minimum number of keystrokes to get me where I need to go. But most users don't have that background knowledge. So we should actually start looking at other ways that we can get this information. Who is a typical user? Can you talk to them? Can you find out what they do on a typical day? Find out the tasks that they do 5 times, 10 times an hour, every hour. And make those slick. Automate them if you can, but make those slick, because those are the things that's going to save people massive amounts of time, rather than the things that they do once a year. Those can take longer. Those can be a bit clunkier, because you're optimizing for giving people joy, rather than sort of working on, how can I phrase this? It's been a while since I've given this presentation. But you're there to give people joy rather in the daily lives, rather than one moment of their lives. And I would add in, because I always do it, try to add in, what about accessibility? What about the people who have poor motor controls, people who are partially sighted, people who have like some mental disorders, or people who are colorblind? Anything that you can imagine, people will use your software. We have had a case where I was working on a product where we went to see the client, and the client was partially sighted, working in high contrast mode. We had white text on a white background. How is that person supposed to cope? But they did. They didn't complain one bit about that, because they were that used to tools for developers being that bad that they didn't even think about complaining and making it easier for us to, or telling us to make it easier for them to do their job. But if you build that in from the start, it makes things a lot easier for those customers. So, yeah, some useful tools that you can use, but you don't have to use to make this work. So don't repeat yourself. Well, do repeat yourself, please, for quite a bit of time. Because until you know that there is a common solution, don't try and build one. We often find that we've overgeneralized to the point where there are special options that each implementation uses individually within that interface. You've not made something that's then generic. You've just put lots of if statements in something. So let's just actually write it. Write it again. Write it a third time. If you've written exactly the same code and it means exactly the same thing, then think about like refactor to a common implementation. But I would also say, if it just happens to look like something else, but the meaning of the code is different, then you don't. It's about when you need to change things. So really, I will stress, copy and paste for a while is not a bad thing, especially if you do domain-driven design and you're doing something like bounded contexts. Don't share code between those two contexts if you really can help it. Copy and paste code, because otherwise you end up coupling two concepts together. If you move into microservices for each bounded context, you're then coupling deployments of things together because algorithms are changing separately, or the shared code is changing in one place. So you then end up coupling them together in ways that you don't really expect. So if you see repeated code, think heavily, but do think about refactoring at some point. I'm not going to go through all the solid principles. I'm sure that everybody here has probably seen some of the solid principles before. But one of my pet hates on the solid principles is the fact that most languages make it hard to actually follow some of them. So like Liskov substitution principle is really hard to follow in C# because of exceptions. You never know what exception is going to be thrown. So therefore you can never catch the specific kind of exception. I try to always create an interface and a set of exceptions that the implementations then throw, wrapping their internals. And then I try and enforce that by using contract tests, where you write against the interface, but then but you test all implementations of that interface, that they will then throw the same type of exception. For example, if you can't find a record, you don't get a SQL Server exception, you get a typed exception, but you can do that via contract testing. But how many times do I see catch exception in the code? Mostly that's because people don't know what exceptions are going to be thrown, but they want to do something every time an exception is received. So again, I like solid. I like keeping things singly responsible. I like interface segregation. I argue with Joe Stead about whether you should create an interface with only one implementation. And I like the open-close principle. But again, they're only principles. You have to put some thought into how you're going to apply them. And I think one last thing on the open-close stuff, make it so that your code is easy to delete, not that your code is easy to modify. So you should be able to write a new thing that implements the interface that you're talking about, rather than, and then delete the old one once it's working, rather than changing the old one. So make your code easy to delete, and I think you end up with a much cleaner system. I also am quite in favor now of using commands and queries. So rather than having the typical layered architectures of repositories that, like a data access layer and a business logic layer and a UI layer, start by firing commands and queries out to the system. Queries, they're exactly that. You ask for some data from the database, but you're specifically asking for something that's meaningful. You're not asking for a generic list of users. You're asking for the user and their usernames. You're making a query that's tied to the thing that you need to do right now. It seems like you end up writing a lot more boilerplate code, but you create very specific pieces of code for that query, which means that it's easy to delete. I can change very quickly that one query. I can write a new query to exhibit different behavior without having to affect anything else that touches that database. And the commands change the system, but they do not return any data. So you're maybe except for an ID, but your command is there to actually make some changes somewhere in your system, change some state somewhere, make some action happen. But they're exactly the opposite of queries at that point, but they're still the same kind of concept. They're still the thing that they're very specific to one event that's happening in your system. So a collection, for me, of commands and queries forms a microservice, forms a bounded context. And they're working on a very specific part of the data. They make the changes to the data, but you don't need as much complexity in the hierarchy. You don't need a multi-layered system to make that happen. You're getting much closer to sort of the domain at that point. And, still use design patterns. They've existed for a while. Don't use the gang of 4. There are other better resources in C# for doing design patterns. But they have a name. They express intent. A factory is something that produces something. So you should be able to understand that just by looking at the class name. But a lot of people, a lot of new people to design patterns, will never have heard of them. So there's a learning curve there. And if you end up with a foobar strategy build a factory, then maybe you're doing something a bit wrong. Like if you've combined 15 patterns together to make something happen, then maybe you've gone a little bit too far. I've seen code bases that have become too complex by having too many design patterns in them. And yeah, I tend to think that I will quite happily use factories. I tend to use factories over DI for most part, just to simplify the need for a DI container. But then I tend to think that if you're doing commands and queries, then I've got lots of very small bits of code that have very few dependencies, so I can actually make them much simpler. They're much easier to create. And something I'm not going to go into huge amounts of detail on is something called Connaissance, which is a way of talking about coupling in systems. And the idea is that you have static and dynamic coupling types, and what we want is to get to the weakest form of coupling that we can. You can't have a system without coupling. You can't have any two systems talking to each other without some method of coupling to each other. You can't have any processing happening without instructions knowing that there's a next instruction along and another instruction. But you're trying to get away from the idea that, for example, the connaissance of meaning. Well, if I've put string order date onto my API, any old string can be passed in. People don't know. I've given the name has a meaning, but somebody has to know to pass in a date. But what format is that date? How's it got to work? Whereas if I go and move that to connaissance of type, which is a weaker form of coupling, so I put it as a date time, then automatically people have got more of an understanding of what needs to be passed in there. And the worst of all cases is the connaissance of identity, which is singletons. And singletons are generally quite bad, but I think probably one of the best instances of singleton that I've ever seen or heard about was back in, I think it was 2003. Netgear routers were all shipped with a single time server address for the University of Wisconsin. And every 3 seconds, they were pinging that address to get the time signature. And what happened over that period, what happened to the University of Wisconsin during 2003? 100% of their bandwidth was being used on serving time for these Netgear routers. Now, this wasn't configurable. There was nothing they could do for these routers anymore. They put this singleton instance into their code. They made their code depend on this one singleton instance, And the university moved its time server. It had to move its time server. There was nothing they could do because there were thousands of routers out there killing their network. But then what did that do to those routers? I don't know. Was there an effect of time slowly going out of sync on those routers? Or did they fail? Did they fail because they couldn't get a time signal anymore? So I would really suggest that people look at Connaissance in detail, and it really does give you a position by which you can start talking about where the coupling is in your system, and really then start tackling them based on the other two parts of Connaissance, which are, so this is the strength that you see up here, but you've also got the locality. So if you've got things coupled within a function, well, that's fine. If you've got things coupled within a class, not too bad. If you've got it coupled within assembly, again, not too bad. The further away you go, the more dangerous that coupling becomes. And also the number of instances. So if you've got only one thing that's coupled to something else, that's not too bad. 10,000 things coupled to the same thing makes it a much worse thing. So using the strength combined with the locality and the number of instances gives you a way of approaching this more systematically and approaching what areas of the code you need to refactor. So, in terms of layers of code, I want to focus on one layer of abstraction. I want to be looking at my API design without having to worry about whether I'm talking to which database I'm talking to or not. I want the API design, I want that level of abstraction to fit in my head. I want to be able to think about, if I'm looking at the logging, I don't care who's calling the logging. I want that logging piece to be a simple piece of code that I understand how it's going to work. I want to trust the API because I've been given an API to work with, so I want to trust that the code is going to obey the API that we've been given. For the most part, I believe in self-documenting code. Where possible, I want the names to be clear. But I still think code comments are useful at times. That may be offensive to some people. I know I have arguments at work about this one where people are on the document everything side, document nothing side, and there's me somewhere in the middle, depending on what is there. I want to see tests. I really want to see tests of APIs. I want to see examples that work. If you can work with an API and you can see an example that actually works, it's awesome because you can build off that. Whereas if you see an API, if I'm working with a third-party library and their test doesn't, like their example app or test doesn't work, yeah, move on to the next. So always think about putting tests and examples that actually work if you're building libraries. I want the system to be decomposed into components so that I can actually understand how the system interacts. I want to be able to see the interaction between those components. I want to know whether they're using event-based interactions, whether they're using RESTful actions. I want to see if they're using both, and I know at what level or at what times they're doing different things without having to care about the implementations. And something that we don't always think about, unless you're a DevOps team, is what happens to operations. If I'm building a distributed microservice application, how are operations going to cope with all of this? So that means you've got to think about what's happening with monitoring, logging, everything that they need to be able to do, failovers, recoveries. Operations should be at the heart of what we're trying to design when we're doing the high-level architecture. In your service API, I want documentation. I want examples. I want to know that you're obeying a versioning strategy. Because I want to know if you're backwards compatible or not. Dylan Beatty does a brilliant "You Give Rest a Bad Name" song. And one of the lines from that is, "Your every release brings our system offline." I don't want that to happen. So you have to think about versioning, how you handle messages from your customers so that you don't break them. Are you going to give sensible error codes and messages? Or are you going to say, nah, everything was fine, 200 OK? Oh, there's an error in the payload. Even worse, we had heard today, the error was a please contact support with this error code to find out what the error was. Where are the long-running processes? Where are the background processes? Document what's happening, and how will I know if that process is completed? So if you have a long-running process, I shouldn't have to sit there kind of holding a connection open, waiting for something to happen. Do you do that via callbacks? Do you do that by me polling another endpoint or polling the same endpoint? Let me know how to find out what's happening. Then I can use your service efficiently. And things I want to see are clear with class design, is like really clear naming of methods and properties. Well, not that many properties would be good, but make sure that you tell me whether it's thread safe or not. If you're writing a class that isn't thread safe and I use it in a system that should be, we're going to have problems. And in terms of what level of documentation, I think on a public interface that's publicly accessible for your assembly, I think most things probably should be documented, but please don't do string connection string and the documentation says the connection string. If you're not going to add anything more than the name, don't document it. Because I've read tons of documentation that's like that, and it gives me nothing more than what's there. Also, the more documentation you have, the more it's likely to go out of date. But more importantly, my view is, explain why you did something. Why have you used this pattern over something else? Because that will actually help people understand the thought process that went into creating this class. So let's get into a little bit of like class or interface design. This is something that I saw in an application from many years ago. You could assign the parent, you could initialize the component, you could register a child component, and you could also call a setParent method. There's several things here that seem to be a bit weird for me. So if I init before I register the child, is that okay? Do I init before I set the parent? Do I set the parent before I set init? This is now coming to connaissance of execution, what they would call, that something needs to happen before the others, or I don't know if it does or not, but I know that init had to be called first. But I only found that out by going through the code. So now, using this class, I've now had to go outside of where I was wanting to work. I've now had to take a step back. It's less reasonable for me, because now I have to think about all these different interactions. If I call register child, does it set the parent on that child? Or do I have to set them independently? How do I know what this class is going to do? And I really don't know. It's disposable as well. So what happens if I register a child after disposing? There's so much stuff in this like little interface that makes it harder for me to reason about. This one is just another thing that I saw where if you're connecting to SQL Server, you connect to a database, and somebody wanted to be able to connect to the master database on that SQL Server. So they created the master connection details, and they created a method on iConnectionDetails that said master connection. But now, I can just go connection details.masterconnection.masterconnection.masterconnection all the way down, and it doesn't make any sense. This probably shouldn't have been a responsibility of the connection details. It should have been something that was extracted out, given a connection, details. It should have been able to, basically a pure function, that you pass it a connection details and it returns you the master details. It didn't belong on this interface. But now it means that the master details and master connection details has to implement itself and return itself. It's just a very weird pattern because somebody wasn't thinking about the clarity of the interface that they were doing. And even in simple lines of code, things can go wrong. The first one here, if, now does people notice the difference here? If L1 is greater than L2. For a long time I read this as if 11 was greater than 12. And I was sat there going, are you trying to trick the compiler? Is there some weird trick going on here? But actually, it took me far too long to reason about one if statement with one Boolean operator. We all know how combining Boolean logic can be tricky. But if you don't name your variables well, you can still do the same thing. And if I ever see anybody doing this, again, I'm going to go mental. That nested ternary operators make it really hard to understand what's going on. So don't make me think about what I'm writing. If you have to extract a variable to make it clearer, if you have to rename a variable, if you have to pull out a function or a local function to make things clearer, please do, because you're writing code that's for people to read more than it is for people to write. The compiler will optimize most of this out of the way. If you extract variables, if you extract a method that's only used once, it's a private method, only used in one place, that has a descriptive name, I will guarantee you that the compiler will probably do a better job than you trying to optimize your code. So keep it simple, keep it readable, and this will actually improve the quality of your code. And if I can do this one, there, great. This is one of the most brilliant pieces of code I've ever seen in terms of the complexity you can get in 50 lines of code. Can everybody see this, or do you want me to expand? So, what we have here is some kind of expression class. We have a node internal to it, and we have a tuple of string and string. Already, I don't know what string and string does. What does the item 1 mean? What does item 2 mean? No idea. But let's go a bit further. So, the constructor sets the value, which calls this convert from with and out parameter passing in the node that we have. Okay, so that sets base values. What is base values? Well, base values is yet another property that comes down here. So now base values is set by this one, but if the value and the base values are not equal, then we set the base values to be the value and null out the node that we just got as the out parameter of that method that we were calling. So, okay, that's a bit weird. So, what then happens if we call expression.type? Well, type asks for the node property and gets the type out of the node property. The node property, now I think I'm right in this one in assuming that node is currently null. So if it's null, it sets the value again and goes through that entire cycle again. Now, to me, in 50 odd lines of code, I can't keep this in my head about what's happening and when the properties are going to call each other or set each other and how this is going to work. And I've no idea what item 2 means in this setter. This is production code where some of the names have been changed to protect the innocent, that we've seen from a friend of mine actually pointed me at this, and I'm still trying to get my head around the entire complexity in this one bit of code. It works. There are 0 tests, but this code actually works, but nobody wants to go near it. Nobody wants to touch it because nobody understands how this code is going to work. So I don't think really this code is that reasonable, in my opinion, anyway. Good. So, does anyone have any questions? I generally would like, not necessarily as a hard-coded rule, but if you can think about, if your class is going over a screen, then to me there's a lot that's going wrong, or potentially going wrong. It's just a smell, a warning sign. But if the algorithm needs you to have more than 7 lines, and you can't break it down any smaller, by all means. But try not to have too many things happening within one method. That generally is, yeah, there is that theory, yes, that people can only hold 7 items of information in their short-term memory. So therefore, if you have more than 7 things there, then you can't, then you can't completely comprehend what's going on in that method. I mean, I've seen classes with constructors that take 29 parameters. So that's violating that rule slightly. But I've no idea what those classes did. I've seen, well, the worst that I've ever seen was one class over 40,000 lines, split across 3 files because it was a partial class to make Visual Studio run better. That was called work, and it had the method do. It had one responsibility as far as the person who wrote it was concerned, to do all the work. But it wasn't necessarily something that I would consider reasonable code at that point. Any other questions?
A lot of what you've talked about is sort of talking around self-management and managing, sort of being aware of some of the things that you might come across. How do you think that works with trying to get some of these principles across to sort of junior members?
So I forgot to repeat your question, but the question that you just asked was, how do you get these kind of self-management practices and disciplines pushed to junior members of the team or new members of the team? My view is that pairing is the biggest way of making sure that people do this, or good code reviews, so that you, as a reviewer or as a pair, it's your responsibility to hold those values almost more tightly to some extent, that you can guide people along to bring them through to that the way that you think. But sometimes it can be hard. We had Dan North in, and he was explaining something that said, it's really hard sometimes when you're at the expert level, kind of the unconscious competence level of ability in the Dreyfus model. He was saying that it's really hard to get that person who's become instinctive on how you hold yourself to account and how you write code to teach somebody who's a beginner. So often your best way is to get people who are now consciously competent, people who've just gone through all this process, they've learnt all the rules, they know what the rules are, and they're still consciously having to do them to train newer people to bring them into your team, so that your more senior people are guiding the consciously competent people into more complex areas and more different ways of thinking. Anything else? Right. Right, thank you very much.